Hello guys, welcome to this week's Math 136 video. Today I'm going to talk about integrating partial fractions. When we integrate a rational function, we apply partial fraction and decompose the rational function into a sum of elementary rational functions, either of the form a over ax plus b to the nth power, or of the form ax plus b over ax squared plus bx plus c to the nth power, where the bottom quadratic function has no roots. The question for today is how we integrate functions like this. For the first type of elementary rational functions, the integration is actually pretty easy, and I'm going to leave this as an exercise for you guys. Find the antiderivative of a over ax plus b to the nth power. What about the second type here? We're going to start with the case where the bottom degree n is equal to 1, and let's consider the following example where we integrate x plus 1 over x squared plus 6x plus 13. How we solve an integral like this? The first step is to complete the square on the bottom of this rational function. We have x squared plus 6x plus 13. That is equal to x plus 3 squared plus 4. Now the original integral becomes the integral of x plus 1 over x plus 3 squared plus 4 dx. And the next step is we're going to apply the substitute by setting u is equal to x plus 3. That implies du is dx, and x is equal to u minus 3. And after we substitute everything back, we get u minus 2 over u squared plus 4 du. You can see that after completing the square and apply this substitute, our integral is simplified. At the start, we have this middle term 6x on the bottom, but now we only have a degree term 2 term u squared and a constant term 4. Now, how do we solve an integral like this? We first separate it into two parts. This is the sum of the integral of u over u squared plus 4 minus 2 times the integral of 1 over u squared plus 4. We are going to do the integration separately for those two parts. Let's start working with the integral of u over u squared plus 4. This integral can be solved by a very simple substitute by setting v is equal to the bottom part u squared plus 4. And after this, our integral becomes 1/2 1 over v dv. The antiderivative is 1/2 natural log absolute value of v. And we get 1/2 natural log u squared plus 4 plus c. You can see that I dropped the absolute value here. The reason is that u squared plus 4 is always a positive number. Therefore, we don't need to take the absolute value anymore. So that is the first part of the integral. What about the second part? I'm going to do the second part on the right-hand side here. What is the integral of 1 over u squared plus 4 du? The way we solve an integral like this, the first step is to factor out the constant term on the bottom here. That means we write our integral as 1 over 4 times the integral of 1 over u squared over 4 plus 1 du. And this can be written as 1/4 the integral of 1 over u over 2 squared plus 1. Now, let's apply the substitute by setting v is equal to u over 2. And after the substitute, this guy becomes 1 over 4 times the integral of 1 over v squared plus 1 dv multiplied by 2. The antiderivative of 1 over v squared plus 1 is arctan v, and therefore in the end we get 1/2 arctan u over 2 plus c. Now we have both parts of the puzzle. This original integral that we started with becomes 1/2 natural log u squared plus 4 minus 2 times the second part of the integral. So in the end, we get arctan u over 2 plus c. For the final answer, we need to substitute u is equal to x plus 3 back, and therefore we get 1/2 natural log x squared plus 6x plus 13 minus arctan x plus 3 over 2 plus c. So this is the final answer for this question. So this computation answers the question of how to integrate a rational function like this when n is equal to 1. And most of the cases you're going to encounter in this class are of this form. But I'm going to say a few words about what happens if the degree n is larger. So let's consider the following example. How do we integrate x plus 1 over x squared plus 1 squared? What I'm going to do is to give you a few hints about how to solve this question and then leave the rest as an exercise. The way you do this is to separate that into two parts, x over x squared plus 1 squared dx, and also we have 1 over x squared plus 1 squared dx. So the first part of the exercise is just to solve the first part of the integral. And the second part of the exercise is to solve the second part. The first integral should be pretty easy. I don't need to give any hints on that. And for the second one, you should try to use the trig substitute by setting x is equal to tangent theta. So try this trig substitute and see what you get. You will be able to find the answer pretty shortly. And this is all for today. I will see you guys in 2 weeks.